let's find some nth roots. We're going to find the indicated real nth roots of a. So remember that we have n and then radical a. So n is our index, so that is what they're giving us. And remember with that n, that's how many of each we need in order for it to be perfect. And then a, the number inside the radical, is called the radicand, and so that the negative 216 here will go inside. So let's write what we have. We have 3 is our n, and a is negative 216. So we'll write 3, and then our radical, and negative 216. Now it's odd, so we're allowed to have a negative value, and we're only going to have one real nth root. So remember from our chart above, one real nth root if it's less than 0. And so 216, that is actually going to be 6. And I know you'll get used to these numbers as you see them. Okay, so negative 216 is really 6 to the third power. But since it's negative, we're going to have negative 6 times negative 6 times negative 6. And so we have 3 negative 6s, and therefore the answer is just negative 6, one real answer. Now let's take a look at n is 4 and a is 81. So we're going to write 4 as our index. It goes inside of that little v part of the radical. And then we have 81. So again, the 4 means I need 4 of something in order for it to be perfect. And so let's write 4. 81 we can start to break down. 81 breaks down to 9 times 9. So that's not enough, right? I have 2 numbers, which is great. Now with square root, we would have been done. But with a fourth root, we actually need to break it down even more. We need 4 of something. And so 9 breaks down to 3 times 3. And so we'll see that we actually have 4 3s. So 9 times 9, that is 3 times 3. The other 9 times 9 is also 3 times 3. So notice we have 4 3s, and so that is our answer here. Now we have to remember that this is an even root, right? An even index, sorry. N is 4, and so remember if we have a number that's greater than 1, we have 2, and it's going to be plus or minus 3. And the reason why is because we could also have fourth root of negative 3 times negative 3 times negative 3 times negative 3. Okay, and it's an even values. So just remember, negative times a negative will be a positive. Another negative times a negative will also be a positive. And so therefore, we will still get positive 81. So that's why there are 2 solutions to an even root. So try out these examples here. Find the indicated real nth roots of a. And so just plug it in. Write the problem with your index, the radical and the radicand, and try these out. All right, if you tried this out, fourth root is 16, so you would start with 4 and 4. So we don't have 4 values, so we need to break it down even more. So we break it down to 2 times 2 times 2 times 2. And then, so we do get 2, but remember, because it's even, we actually have the negative 2 as well. So just looking at it, we have negative times negative times negative times negative will also get us a positive 16. So it has, the signs, everything has to be the same. So this is a plus or minus 2. Now you don't have to write that out, but I just wanted to prove to you why it works. So you just have to know these rules. If it's greater than 0, we're going to have the plus or minus. If it's less than 0, then it doesn't exist. And so notice with number 2, it's even. It's a negative inside, and so there's no real nth root. So again, you just have to memorize it. But just to prove it to you, we can't have negative 7 times negative 7, right? We need 2 of the same value with the same sign. Negative times a negative would be positive, which is not the same. Positive times positive is still not negative 49, so therefore that still doesn't work, right? Both of those don't work. The only way to make negative 49 is with the 7 and negative 7, but they're not exactly the same, so it doesn't work. It cannot come out. And so therefore it is no real nth root there. So if you tried number 3, so cube root of negative 125, you can think of 25 times 5, and then break down 25 to 5 times 5. So there are 3 negative 5s here. Negative 5 times negative 5 times negative 5. would still give us negative 125. So we have 3 of the negative 5, so the answer is negative 5. Then we have fifth root of 243. So we can break down 243 into 3 times 81. And then 81, if you remember from earlier up here in this example 1, 81 is really 4 3s. And so I remember that. And so we wrote 4 3s here and another one. So we have 5 3s. And so you'll start to memorize that, right? You'll see these numbers very often. There's not very many numbers we could use because they get very large. So we'll notice that 243 is really 3 to the 5th power. So this answer is 3.